Hello, our learners. We thank you for following us, for subscribing to us. So, we are going to continue with our daily discussions. So, today we shall be discussing basically about generators and transformers. So, we shall basically look at some few questions which maybe can give us some troubles whenever we meet them. As for the first one, it's the question which is on our screens, which says a generator with a power output of 20 kilowatts at 40 kilovolts distributes power to a workshop along cables having a total resistance of 16 ohms. Calculate: 1 is the power in the cables, 2 is the current in the cables, and 3 is the potential drop between the ends of the cables. So whenever you're given such a question, the first thing that you do is to write down what you're given in the question. So from this question, what we have, first of all, we are given that the power output equals 20 kilowatts. So if I'm to write this down, it means that the power which is output, if I call it power output, basically this is power output. This is equivalent to 20 kilowatts. Then if we look at what we have, we also have at 40 kilovolts, or output of 20 kilowatts at 40 kilovolts. So because we are dealing with primary and secondary coils, so that means that the potential of the secondary coil, if I call it Vs, it is equivalent to 40 kilovolts. Remember, when dealing with generators and transformers, we have what we call the primary coil and the secondary coil. So it is distributing power to the workshop along cables of resistance, which is 16 ohms. So maybe we can also write down the resistance of the cables which we are given, which is 16 ohms. So the resistance of the cables is 16 ohms. So looking at the solutions, part A, they want us to calculate the current in the cables. So the formula for finding current, of course, we first look at what we have in our question. We have power output. That is, the power output is the same as the power which is in the secondary coil. So we also have the electromotive force, or the potential in the secondary coil, which is 40 kilovolts. So to find the current in the cables, we are basically going to use the formula for power, which is power is given by the product of current and voltage, which is IV. So power is given by IV. So the next thing we have to do is just substitute in that formula of power equals IV. So if I substitute for power, which is 20 kilowatts, actually, if I just first make I the subject of the formula, the current I will be given by power divided by the potential, which is V. So if I substitute what we have, power is 20 kilowatts. So since it is a kilowatt, it means that we multiply the 20 with 10 power 3. So it is 20 times 10 power 3 to convert kilowatts to watts. This is divided by 40 kilovolts is the same as 40 multiplied by 10 power 3, since it is in kilovolts. 40 kilovolts is 40 times 10 power 3. Oh, sorry, it was 40 kilovolts, 40 times 10 power 3. So if you work out this, you end up having 20 out of 40, and the answer will be 0.5 amperes. So the answer for current in the cables is 0.5 amperes. So part B, they're asking us to find the power loss in the cables. So for us to get the power loss in the cables, one thing we should know is that in generators or in transformers, power loss is always due to resistance in the cables. So it is the resistance in the cables which causes power loss. resistance in cables is the one which causes power loss in transformers or in the wires that are used in transformers. So meaning that the power loss is always, so this is part 2, the power loss is always by the resistance. So power loss is always given by I squared R, that is, power is lost by I squared R mechanism. So since we already have I and we already have the resistance, then the power loss will be given by, we just substitute I, which is 0.5. We square it, we multiply by the resistance. The resistance is from up, the resistance of the cables is 16 ohms. 16 ohms. So we multiply 0.5 squared times 16, and we end up getting the answer as 4. 4. The answer is 4. Since we are dealing with power, the answer is 4. 4 watts. 4 watts, because we are dealing with power. Then part 3 is the potential drop between the ends of the cables. We know that the word potential drop sometimes, or it also means electrical potential. There are many words we can use for that. One of them is electrical potential. Another one is we can use the word potential difference. Same. We can also use what we call voltage to also mean potential difference. So since we already have current and resistance, so we are going to use the Ohm's, the mathematical representation of Ohm's law, which represents electrical potential or potential difference, V, as being equivalent to I multiplied by R. So the value of I, we got it as 0.5 amperes, and we have the resistance as 16 ohms. So we just multiply 0.5 times 16 and we get the answer as 8 volts. So the electrical potential is equivalent to 8 volts. So finally, we've answered the whole question as it was given to us. Otherwise, thank you for following us. Please search for more of our lessons and continue watching and subscribe to our channel to enjoy more of our lessons and videos.